All right, so today we're going to look at the different types of regressions that we can have. On Friday, all we had was linear, but we learned how to get that equation. We learned where all of that is. We learned to turn our stat diagnostics on, right? For those of you that don't know that, that's usually under your mode button, but that's your R value. So if you're missing that, I will help you find that when we get to that point. We have a couple different types of regression that we are going to look at. What you see up there is the name, but then you also see the abbreviation that is happening in your calculator. And being able to match those up is kind of important. The stars don't really mean anything. In fact, this star should probably be down on logarithmic. It's kind of the ones we use most often, but it's really not going to impact anything. A couple things to note on this. All day, our entire lesson on Friday was all centered around linear regression. Our dots formed a line. We learned that there are two linear regressions in our calculator. We are going to pick option 4, the one that said ax plus b. We will not use option 8 that says a plus bx. Quadratic regression would be the one you would have used for your warm-up today. If you looked at that and you see a shape of a parabola, it doesn't matter if it's upside down or right side up like you guys saw. That's a quadratic regression. Power regression and exponential look very similar, and we'll talk about how to tell the difference between the two of those. Logarithmic regression is going to level off at some point. And this is one right here. I would say this one right here. Everyone forgets how to find that one because it doesn't say logarithmic, it says natural log in your calculator, which is a logarithm, right? So your problem would say the word logarithmic. It will say use a logarithmic regression. And then when you go to look at the list, you have to find natural log. So remembering that they pick log base e in your calculator to do the regression as, and not just a log base 10. But your problem would literally use the word logarithmic because it is logarithmic, okay? And then this one right here, I'm going to kind of section this one off. This one is all day tomorrow. So this would be 3.5 day 3 is all about this thing called logistic growth. And logistic growth is actually way more real world applicable because it models real world growth a lot better than like exponential, but the data is very different. And so what you'll find is if you were to try that one out today, you accidentally maybe confuse it for a logarithmic regression or something because it starts with the word log, that your calculator is going to give you an error message because the data is so different for logistic growth, and your calculator is going to know that what you told it doesn't work for that it'll give you an error message. So if that ever happens, you probably just picked the wrong regression type, okay? Anyone still need this page? All right. So here's what we're going to see. You're going to see basically two types of questions today. Is that you're going to see it say what type of regression to go pick. Like in the first two examples. This one straight out tells us that we are going to do an exponential regression. So here's what I need you guys to start with doing. Fill in the bottom of your table on your note sheet with 1,130. And then go to your calculators and fill in list 1 and list 2. And then we'll go find the exponential regression. All right, and my people that were gone, if you don't know where to put this, I'm going to go ahead and put these numbers in my calculator. To enter data, we go to Stat and pick option 1, Edit. I have numbers in here, so I'm going to go ahead and clear those out. I highlight the title, hit Clear, go down, go up, highlight the title, hit Clear, go down, and then I can fill in my numbers here. anyone else gone Friday that I didn't check your calculator? And I'm going to need to look at yours later. Just making sure our stat diagnostics is still turned on, which we'll come to later. Okay. Now, it did not ask me to actually graph it. You can totally graph it and look at the picture. All it asked me to do is write the, remember, fancy word for equation is model. So they might say write the regression equation. They might say write the regression model. And then we're supposed to use that model. So use my fancy word for equation, right? But when I go to get this, they told us exponential. So we go to our stat, the same place that we got our linear regression, we get our exponential. So arrow over to the calculate. And let's find all of our options here. Friday, we exclusively used option 4, linear regression. Here are the other ones. There's quadratic, which would have matched our warm-up, right? We don't really use cubic or quartic. We will not use linear regression, option 8. There is your logarithmic, natural log. Okay, so if we ever need a logarithmic, it's option 9. If we keep arrowing down here, we've got other options. There's your exponential, which is the one we're about to use. Power was another one we saw at the beginning of today. And this is tomorrow. Logistic growth will be all the way down there at the bottom. So we're going to use option 0, exponential regression, because the question prompted us to on this one. Okay, so when I go to that, it's going to look very similar to my linear regression. We see this screen pop up. I go down to calculate, enter calculate. It gives me the format. Please make sure that everything we are doing on all problems ever, every number I write down are always rounded to 2 decimal places. We'll do hundredth for everything. Yes, so let's talk about the little star that's there. Guys, you don't need to write a star down on your paper. What symbol is your calculator trying to say? Multiply is what that little star is supposed to mean. Okay, so we just write them next to each other with like a parentheses or something. We don't, that would be unnatural for you to write a star because it's probably the first time you've ever done it for a multiply, right? So y equals, round to my 2 decimal places here, so 399.57 times 1.19 raised to the x. That is my exponential model. Then on most of these problems, they will ask us to use our model. Fancy word for use the equation we just wrote down, right? And then we have to slow down and interpret. Are they giving us an x value or are they giving us a y value by the question? So if we look at our question here, use your model to predict how many bacteria there will be after 24 hours. Are they giving us x or y? X, right? We saw on Friday all horizontal tables. Vertical tables goes the same order, x, y. So they just gave us that x equals 24. We're going to go ahead and plug that into our equation right there and grab my calculator and type that in. I will warn you that I have checked. If you check your answers with the book answers, like you have a book assignment today, guys, they don't ever round. Like they would keep with that big long decimal that you see in your calculator. So we will be very, very close. There will be some numbers that we will be a little off, and that is why, if you're like, I don't understand why it's off, the book will not round. So when you get to like worksheets that I put my work on, we should match identically, because I will round to 2 decimals just like you will round to 2 decimals. But books have the ability to not round ever, okay? So like, go ahead and grab your calculator and type that in. We are looking at how many bacteria we would have after 24 hours. Glance at your table partners. Make sure you guys match, especially the rounding part of it. I circled a lot of rounding on our last test for doing it incorrectly. Do I have a table that agrees? Okay, Brogan, what do you guys agree on? Yeah. 25,000, sorry, you were too fast for me. 0.83. Perfect. Okay. Any questions on the new types of regression? Okay. You and your table partner are on your own for this one then. Did you figure it out?
There's a scatter plot, right?
Uh-huh.
I press it and then that comes up, but I don't know how to separate the numbers. I have no idea. Because I like tried to.
Did you type them into a list?
I did it into a bracket. I did it in commas.
Did you type your data into like a list? marked anywhere?
If I just do this, press enter, so it says define a new list by enclosing commas separated with
Go to your vars menu. Let me see what's on that. What do we have for it?
none.
Okay, clear out of this screen. Give me like a plain home screen type of thing.
Okay, that's
Okay, now
that.
try.
And then if you want to do anything, you have to press menu. It's confused. I may have to talk to Miss Geiger
Yeah. Try
because she knows this. But
table. Yes, talk to Miss Geiger. She teaches this, so she would know exactly probably what's going on with this. You're going to go to Stat and Edit. And then if there's numbers in there, you highlight the heading and hit clear. Nothing's going to happen until you arrow down, and then it'll clear everything out. And then you type all that in. Yep. Mm-hmm. Let's see what's going on. Let's go to. Okay, it's not liking where you are missing. You only have 6 things in there. We're missing like the 7th one, maybe?
Oh, well, first watch didn't even
I think that'll fix it for you. Add that last number in there. 7 and 58.3. Yeah, guys, remember your note sheet's always missing something, so you got to fill it in.
That's what happened on the last
Good
one
job.
too,
Yep.
'cause I didn't fill
Yep.
in that number.
Good job.
I was so confused.
Yes, I purposely leave off a number on your note sheet. Fill it in.
Did we just ignore that? Oh wait. LNX.
Nope, that's natural log of x. So that's just
So how
at.
do you write it?
So 73.09. Yep.
B,
So
or
minus 7.31 times natural log x.
Is this supposed to be a
That's
tiny, tiny number?
I don't believe so.
Well, if you raise that to the 0, it's going to be a tiny number, and multiply that times that.
Minus between them, not multiply.
Oh yeah, it's a different equation.
It is. Yeah, I think it's a minus between them. It's a logarithmic, not exponential. So it should be times natural log of x. I think like 8 something like that. But yeah, sure. Okay, guys. Hopefully we're helping each other out as we were going through this one, getting our data into our table. Yes, remember, as we go through all this, including today, tomorrow, I always leave something off of your note sheet so that you are with me here. You had to pick LN. Yeah, LN, natural log. So LN regression, which is option, I believe, 0 on that list. You have to scroll down a ways. So, Sailor, can you give me the numbers? 73.
Yeah, 73.09 minus 7.31.
So, guys, when it asked me to write out the model, I'm having a lot of people having questions on the logarithmic one. Okay? Remember that LN stands for log base E. So and I put it as a cursive L right here for the sheer fact that some people think it's a 1 or get confused with what it is. It's LN, natural log of x. So it is multiply, it's squished up right next to it. Okay? And then they do this, I put this one in the notes. It's a very basic example of, but sometimes on these problems, they will try to trick you by giving you a question in a different unit than what you created your function in, right? So when they asked us, use your model to predict the average test score after 2 weeks, what did you guys actually plug into your function? 14, because our table was in days. And I'm telling you right now, there's going to be at least 2 more times on your assignment today where they do the exact same thing, is they ask you a question in different units than the problem was created in. So we just do a quick conversion. Yeah, 2 weeks, but we were doing this in days, which means we are plugging in x equals 14 days so that my units match. And then I'm just typing that again. It was an x value. So when it's an x value, we are just typing it in. And a table that agreed on an answer here. 53.8. Okay. Percent, right? If I were talking labels here, it'd be 53.8%. Does that seem to make sense? Probably. Okay, so that's one type of question you're going to have where it directly tells you which regression equation to use. The other type of question we are going to have is like this last one. Use the data in the table to determine a regression equation. Okay, so this time it does not tell us which one we are using. We've got 6 options. So how do we do this? Well, let's start by filling in the bottom of our table with the correct number here. Let's go to our calculators and put this data in. I'm going to do this right along with you, and we're going to figure out how to determine a regression equation. When you type this, like this is a good example, when the numbers are really large, your calculator will round it because it's restricted on space. It is not actually rounding it. It will keep the value in there. It just can't show all of it. So don't be stressed that you have like the wrong number in there. It's keeping all of the number you type in. It's just only being able to display so much of it. Okay, so the question is, we this time are supposed to determine the regression equation. It didn't tell us. Guys, probably the easiest way to do this, you've got 6 options. Look at the picture. We will be able to eliminate multiples of this option, if not get down to just one. For example, if you guys had looked back at your warm-up, I think it very clearly was a parabola, yeah, a quadratic equation. That would have been very easy to determine by the picture. This one is not as easy, so I'm going to go turn my scatter plot back on, right? Go to second y equals, go to make sure my scatter plot's on, zoom 9 to see the picture. And if we go back to our options here, I think we can at least eliminate a couple. First of all, is a straight line going to be our best option on this one? No. So we're going to go ahead and eliminate linear regression for this one. How about, does that look like a parabola? No, it's not quadratic. Does it look like a power regression? Possibly. I would keep that in the running. Is it logistic? No, I already told you that, right? We know for sure nothing today is going to be logistic, and that is a very different type of stuff. It will not be logistic, okay? Does it look like logarithmic? Does it level off? No, it's going up, right? So it is not logarithmic. Could it be exponential? Yeah, so we went down from 6 options down to 4. And you don't have to eliminate anything. You can try all of this out. That is fine. To 2 options. We eliminated 4 options of our 6. So how do I make the final decision between them? It does not have to be visual. You guys don't have to now rely on the picture. There is something that can confirm which one is the better option, called your correlation coefficient, which is letter R. So now we go to our correlation coefficient. Remember, your correlation coefficient says, hey, this best fit line, how close is it to the actual data you handed me? And the stronger it is, the closer it is to 1, the better option that is. And so we just look at anything that I think it is, I check out its correlation coefficient. And if I've got multiple options, pick the one with the stronger correlation coefficient. So I'm going to go check out that power regression. Was that first one we thought it could be? If I do my power regression, remember at this point, if your calculator lost its batteries or you reset it and you're missing those bottom two lines, you need to go turn your stat diagnostics back on because that's what gives us R. And it's got a very strong R value. It's close, right? R equals 0.97. Well, the strongest it can be is 1. 0.97 is very close to that, and normally I would say that that's a really good option. However, when we go check our exponential regression and its correlation coefficient, yeah, it doesn't get any stronger than that, right? That is the strongest it can get, is R equals 1. So now to make my decision which one is closer to 1, well, 1 is closest, right? So we would pick exponential regression. So I would use that equation. Please be very careful, my wonderful algebra students here, on rounding. Something like 999.99999 to the nearest two decimals would actually be 1,000. Right? It's going to round up to 1,000 because I want it to be two decimals, but as I round, the 9 rounds that up, which rounds everything up. So I would have picked exponential on this one. The 999,000 rounds to 1,000 times 1.78 raised to the x. Okay. Now, no. On this one, this is actually the first time we have seen this. When we are handed the question, determine the approximate time it will take for the website to earn a profit of $100,000 in 1 year. $100,000, is that an X or a Y? A Y. We have usually had X's for this question. Now, back up from the problem, we are just solving an exponential equation, right? They gave us that it's 100,000, and we are solving an exponential equation. Our steps to solve an exponential equation that has an exponent on one side, get it by itself, flip to logarithmic, right? You guys all did really well on this test that told me you know how to solve an equation like this. How do I get rid of the 1,000? Divide by 1,000. Order of operations, I cannot multiply those together before doing the exponent, right? So that's why we're going to divide by 1,000 and just get that out of there. Once I get that exponent by itself, we flip to logarithmic, which will become log base of my exponent, right? That's going to be just some number my calculator will tell me, which rounded to two decimal places, 7.99. So almost 8 years. Questions on that? Depends on how the directions, like if they had just had those directions there to determine the approximate time, I would think that 8 would be fine with that. If it specifically said round to, and because I verbally said round to the nearest hundredth earlier, then I would expect that. So it kind of depends on how it was worded. Did it? Um, 1.78. You did 1.74. And now you're good. All right. Kind of. No, they are not given on the quiz.
Yeah, but you can just
Okay.
calculator.
On Friday, yeah, if you were to forget, you could just try out your correlation coefficients and see which one works. On Friday, I told you that this question right here was one of the ones that is the most challenging. So I know it is not on your note sheet, but I want you to take a second and write me a sentence that identifies and interprets your slope, and write me a sentence that identifies and interprets your y-intercept. You do not have to do any calculator work. I am telling you right now, here's your topic. Hours spent studying versus the math SAT score was this table right here, which I did not finish for you. I went ahead and did the linear regression. It gave me this equation. Now use this equation and answer those questions, please. I'm going to give you a minute to try to write out an equation by yourself, and then we'll talk about important things that need to have shown up in your equation. I mean sentence, not equation. Sentence. In your sentence. You don't have to type anything in your calculator for this one. I just use the equation that's below it. So I didn't even give you all the data.
How strict are you going to be on the format of the way? As long as we have like one.
I'll be very strict on 2 numbers in each that correspond to the correct labels. Order and wording, not
Okay, because Miss Preble was strict on the wording.
right. You AP stats?
Yeah.
Yes, because AP is crazy strict about stuff like that. Talk to my Calc kids. Okay, so I had some really good questions about this problem. How strict am I on the wording? Guys, I'm not. But how strict am I about 2 things? You have to have 2 correct numbers in each explanation. Both of those correct numbers have to correspond to the correct label. So let's go ahead and talk through this one. On the topic of slope, first of all, remembering that this is y equals mx plus b. That m is the number in front of x is your slope. That slope always needs to look like a fraction, and we are not going to overthink this. To make a number look like a fraction, we can always put it over 1. That your slope formula, y2 minus y1 over x2 minus x1, you don't need to know that. You just need to remember that it's the change in y's over the change in x's. So you remember which number goes with x and which number goes with y in your fraction. And then as we look at these labels, it is labeled X and Y. That top one, is that your hours or your SAT score? Hopefully our hours. And that'd be our SAT score. So your Y's are your SAT score. So we would say that we would expect our SAT score to go up or increase because it's positive. So SAT score increase. So somehow indicating that it's going up or down, whether it's positive or negative. 25.3 points for every 1 hour spent studying. Okay, the fact that you have that number and that number in there, 25.3 and 1, that you have them with the correct label. The 25.3 goes to your SAT score and the 1 goes with the hours spent studying. Yes? Nope, that's fine. Yep. Yeah, order and the wording, not super important. The numbers, especially, a lot of people will forget the 1 part of this one. Okay, the 1 and the correct labels are the important part. So then the y-intercept, and the important part about the y-intercept is remembering that in a y-intercept, your x value has to be what? 0. In order for a number to, or a line to hit your y-axis, the x value at that point has to be 0. So it would be 0, comma, 353.2. I don't know why I just wrote it as an ordered pair, but just so you can kind of visualize it there, that it's x comma y, hours, SAT score, right? So if you spend 0 hours studying, expect an SAT score of 353.2, something like that, where you identify 0x label, right? That's, again, the key thing on that one that people tend to forget to talk about. 0x label results in your y-intercept. Any questions on that? Okay, guys, we do have some stuff to talk about on your assignment. So if you will get out wherever you are going to do your assignment so you can jot down these couple notes while I end my recording here.